Grid and utility computing, the foundation for cloud computing. Have you ever wondered how vast scientific discoveries or global online services are powered? What if the same computer that helps decode the mysteries of the universe also powers your favorite streaming platform, only through different philosophies of sharing and usage? This is where grid computing and utility computing come into play. Two models that once shaped the evolution of modern cloud computing but serve very different purposes, much like a community workshop versus a power company. Grid computing is built on the idea of collaboration and shared effort. Imagine hundreds or even thousands of computers from universities, research labs, or organizations coming together like volunteers at a charity event, each contributing a bit of their spare computing power to solve a massive problem. The grid acts as a virtual supercomputer, connecting scattered resources across the world. For example, the SETI Home project once allowed volunteers to donate their idle CPU cycles to analyze radio signals from space in the search for extraterrestrial life. Similarly, the Large Hadron Collider at CERN uses grid computing to process immense volumes of particle collision data. In these systems, each node, like a cell in a giant organism, plays a role in completing an enormous collective task. The motivation is typically scientific, not commercial. There's no bill to pay, only a spirit of cooperation and a desire to push the boundaries of knowledge. Utility computing, on the other hand, is a product of the business world's pragmatism. If grid computing is a volunteer network, utility computing is a professional service. It treats computing resources like electricity or water, something you can tap into when needed and pay for based on consumption. The user doesn't have to own servers or manage technical details. Instead, they simply plug in to a provider's infrastructure. Companies like Amazon Web Services, AWS, Microsoft Azure, and Google Cloud are the power plants of this digital age, delivering virtual machines, storage, and data processing capacity on demand. If grid computing is about collective effort, utility computing is about individual convenience. You pay only for what you use, whether it's computing hours, gigabytes of storage, or bandwidth. Architecturally, the distinction is just as striking. Grid computing typically connects resources owned by multiple institutions, operating under different rules, but unified by a shared middleware that coordinates tasks. It's decentralized, sometimes messy, but democratic. Utility computing, by contrast, is centralized. A provider owns the hardware, manages the data centers, and offers polished, standardized services. It's predictable, scalable, and designed for efficiency. In a sense, grid computing is a federation, while utility computing is a corporation. Philosophically, the two also diverge in intent. Grid computing emerged from academia and research, driven by the quest to solve problems too big for any single machine or organization. Utility computing emerged from commerce, driven by the need to cut costs, scale quickly, and provide elastic resources for fluctuating workloads. Grid computing represents the power of collaboration, while utility computing represents the convenience of consumption. In the end, both models laid the foundation for what we now call cloud computing, a hybrid that blends the collaborative spirit of grids with the business model of utilities. Whether you're contributing your laptop's idle power to scientific research or spinning up a virtual server for your startup, you're participating in the grand story of distributed computing. The difference lies not in the machinery, but in the motivation behind the connection. Shared discovery versus paid service, community grid versus digital utility. Both remind us that in the digital world, power, whether shared or sold, flows through connection. Are you inspired by the wave of technological revolutions transforming our world? Have you considered how these innovations could elevate your own project or research? I'd love to hear your perspective. Share your thoughts in the comments below. And if you found this video insightful, don't forget to like, share, and subscribe to stay tuned for more ideas and discussions. Thank you for watching. Mahalo.